All right, guys, we are going to move on from inverse sine, and we're going to start talking about inverse cosine, and we'll also get to inverse tangent as well. Now that we kind of have a good idea, hopefully, of inverse sine and why we kind of do some of the things we do, much like when we did graphing and we spent time graphing sine first, it made graphing cosine and the other functions easier. Hopefully that's the same case for inverse cosine. So what you see in front of you, right, is a graph of regular cosine. We know the domain is negative infinity to infinity, and the range is negative 1 to 1. However, if we were to take the inverse of this, it would not work. I don't know if Miss Austria ever covered the idea of a one-to-one function. A one-to-one function is a function where itself and its inverse is a function, right? So one-to-one just means itself and its inverse is a function. So clearly the cosine function is a function, but its inverse cosine, would look very similar to that weird snaky graph we had for inverse sine. So cosine is definitely not, okay, cosine of x is not, I'll just write this, 1 to 1. Okay, it's not 1 to 1. So the question is, what can we do to regular cosine to make it a 1 to 1 function? And much like we restricted the domain of regular sine, if we restrict the domain, if we restricted the domain in this case from negative pi over 2 to pi over 2, like we did for sine, it still would not be a one-to-one function. It would not pass the horizontal line test. Thus, its inverse would not be a function, right? So if we want to restrict the domain of cosine, to make it a one-to-one function, instead of doing negative pi over 2 to pi over 2, we really should do 0 to pi, right? If we restrict the domain to 0 to pi, that now still passes the vertical line test, but it also passes the horizontal line test, meaning its inverse will also be a function, okay? So if we scroll down below, what can we restrict the domain such that it is a one-to-one function? I would restrict it to 0 to pi. And let's actually graph these two together so we can kind of get a sense for how the graphs kind of look. So we certainly know what a cosine graph looks like, right? It starts here at 0, 1, right? 0, 1, then it's got to intercept at pi over 2, comma 0, and then it ends down here at pi comma negative 1, right? And it kind of takes that shape like that. So what would inverse cosine look like? I'm going to do it in a different color so it's clear. Inverse cosine of x. Well, we know it's going to swap the points. So we've got 0, 1 as a point. So that means this point here would be 1 comma 0. We also have the point pi over 2 comma 0 on cosine. That means we'd have 0 pi over 2 as a point, 0 pi over 2. And then on regular cosine, we have the point pi negative 1, which means the point on inverse cosine would be negative 1 comma pi. Okay, negative 1 comma pi. So if you were to connect this graph, it would kind of look, let's see how good I can draw this, something like that. Okay, it's not a perfect drawing, but pretty close, right? Still should have that kind of wavy look to it. The domain of the graph is negative 1 to 1, and you can see the range, right? The range is 0 to pi, okay? So let's actually see what a nice computerized graph might look like. So there's your graph of arc cosine, which again is the same thing as inverse cosine. And we just talked about what the domain would be. The domain would be negative 1 to 1, including both of them. And then what would the range be? Again, as we talked about a second ago, 0 to pi. So your inputs must be between negative 1 and 1, and your answer will always come out to be somewhere between 0 and pi, including 0 or pi. So when we think about problem number 1, inverse cosine of negative 1/2, well, you have to think of your triangles and the reference angle. The reference angle would be pi over 3. So again, since my range is 0 to pi, I'm really thinking quadrants 1 and 2. Okay, so what angle in quadrant 2 would have a reference angle of pi over 3? That would be 2 pi over 3. Hence my answer is 2 pi over 3. That's where I'd get a cosine ratio of negative 1/2 in quadrants 1 and 2. Positive 1/2, okay? I'll give you a second to think about it if you want, but think about we have the same reference angle. We need to be in quadrant 1. Again, if my answers have to be between 0 and pi, thus my answer is pi over 3. And I'll give you about 10 seconds to think about arc cosine of 1. If you want to think about what that answer would be. Arc cosine of 1, we're thinking where is cosine equal to 1 between 0 and 2 pi. Okay, the only place that would occur, sorry, not 0, but 2 pi, 0, 2 pi, would be at 0. Okay, would be at 0. All right, so hopefully that's fairly straightforward. It's just like inverse sine, except our range is a little bit different. Okay, we also can have situations, right, where we stick one function inside another. Okay, so when you see a case like this where cosine, okay, is in inverse cosine, I can plug in any number in for x. Okay, there's no restrictions on its limit. Now my answer might not come out to be the same thing as x, okay, as we saw before, and we'll see here in a minute, but I can plug in any number for x. It doesn't matter what I plug in. However, the other scenario where the inverse cosine is on the inside, right, where the inverse function is on the inside, my x value has to be between negative 1 and 1. Excuse me, and 1. Okay, so just be careful with that. As we saw before in some of my inverse sine ones, some of them could be undefined because it doesn't fit the domain of inverse cosine. So if you're feeling pretty strong, you could pause it and try the next 6. If you want to walk through a few with me and then pause it to do the rest, you can. I'm going to walk through all 6. I would say whenever you feel like you want to give it a shot, hit pause and then see how your answers match up against mine. All right, so number 1, it's again an inverse inside itself, so it should be the same thing as the inside, provided it's in the domain and range of each. So cosine of inverse cosine of 0.5 is just going to be 0.5. Let me go back to black here. Cosine of inverse cosine of 1.8. Okay, this is a scenario like this guy right here. We are not in the domain, so this one would be undefined. You could write not defined, however you like to define it, no pun intended, undefined. Number 3, inverse cosine of negative pi over 8. Okay, so basically what you should be thinking of, since negative pi over 8 is not going to be in the range, right, of inverse cosine, okay, what angle in quadrants 1 and 2 would have the same ratio as negative pi over 8, okay, and that would actually be pi over 8, right? Hence my answer is pi over 8. Again, we're thinking, okay, my answers in a problem like this where cosine is on the inside and inverse cosine is on the outside, my answers have to either be in quadrants 1 or 2. And the angle we're given, let me switch colors, oops, we'll go to blue, is negative pi over 8. So this angle in here is negative pi over 8. Okay, so what angle in quadrants 1 or 2 would give me the same ratio? That would be positive, right, pi over 8. Okay, because cosine's positive in quadrants 1 and 4. So that's where the pi over 8 came from. In problem 4, inverse cosine of 5 pi over 8. 5 pi over 8 is in the range, okay, of inverse cosine. So your answer is just going to be 5 pi over 8. For number 5, negative 3 pi over 4 is not, okay, in the domain. Okay, so what angles in quadrants 1 and 2 would give me the same ratio as negative 3 pi over 4? Well, that would be positive 3 pi over 4, because that's in quadrant 2. Negative 3 pi over 4 is in quadrant 3. They would both give you the same cosine ratio. And then number 6, cosine of inverse cosine of 1/4. 1/4 is in the domain of inverse cosine. Hence your answer would just be positive 1/4. All right, so that's inverse cosine. A lot of the rules, not a lot of the rules, all the rules still apply. Just the domain and range have switched, or just really the range, not the domain, has switched compared to sine. So just work on those, think about those, keep those straight, and you should be fine. All right, so we're also going to take a look at inverse tangent now that we are experts on inverse functions. Okay, again, is inverse tangent a one-to-one function, would it pass the horizontal line test? It would not. Okay. No. So what can we do to restrict the domain of tangent such that it is a one-to-one function? Well, you might be able to guess. If we restrict it between negative pi over 2, pi over 2, although notice those values would not be included, it then becomes a one-to-one function. So what do we want to restrict the domain to so that it becomes a one-to-one function? We want to go from negative pi over 2, not including. No, those points do not lie on the regular tangent graph. Okay. So your regular tangent graph would look something like that. That's your tangent of x. Y equals tangent of x. And I don't want to get things too messy here, but remember that there are vertical asymptotes at negative pi over 2 and pi over 2 on both sides of that graph I just drew. I'm now going to draw in, well, you know what? Why don't I draw it in just to be safe? I'll do different colors. So there's x equals pi over 2. Here is x equals negative pi over 2. So what would the graph of inverse tangent look like? Well, those vertical asymptotes, okay, as part of the domain would be horizontal asymptotes as part of the range now for inverse tangent. So I would have a horizontal asymptote at negative pi over 2, and I would also have a horizontal asymptote at pi over 2. Okay, when I think about swapping some points, okay, I would still have that 0, 0 point, and my graph would take that shape right there. So when looking at that graph, let me just label that. That's inverse tangent of x. Okay. Again, the way I found it was just swapping x and y values. Okay, swapping x and y values. When you think about it, what would the range be? What would the domain be of inverse tangent? Okay, so let's actually, again, get to a nice looking computerized graph. There's your graph of arctangent. All right, so what's the domain of inverse tangent? It's actually, there are really arrows here, if this is done correctly. It's negative infinity to infinity. And what's the range? Negative pi over 2 to pi over 2. Notice we are not including those values. They are not included. So it says solve for the following inverse trig functions again. Inverse tangent of negative 1 to 1. Actually, before we do that, let's go back and think about the range. What quadrants am I in for negative pi over 2 to pi over 2? I share the same quadrants as inverse sine. So inverse tangent and inverse sine share the same range, essentially. Inverse sine, you would include negative pi over 2 and pi over 2. Inverse tangent, you do not. But other than that, they share the same values, so that's good to link those two together. Inverse tangent of negative 1, if we get back to that, where in quadrants 1 and 4 would I have an inverse tangent value of negative 1? Okay, that would come at negative pi over 4. We need to be in quadrant 4 because we need a negative value for my ratio. Inverse tangent of 0, where between negative pi over 2 and pi over 2 would I get a tangent ratio of 0? That would be at 0 radians. And then number 3, we can skip. We need a calculator for that. And given the difficulties in remote learning as it is and the time we have, we're going to skip any calculator stuff for now. Okay? So when we think about a function like inverse tangent of x, when we think about a problem like that, are there any restrictions on the values I can plug in for x? No, it can go anywhere from negative infinity to infinity, and I'm just going to make a note, right, except, okay, asymptotes, right? So, for example, if the function hasn't been transformed in any way, negative pi over 2, so on. But other than that, you can plug in any value, okay, there. What about tangent of inverse tangent? We saw when we did cosine of inverse cosine, my input had to be somewhere between negative 1 and 1. But when we think about inverse tangent in its domain of negative infinity to infinity, there were no limits on the domain of inverse tangent. So you can plug in any value here. Okay, you can plug in any value in for there. So that's what makes it a little bit different than inverse sine or inverse cosine, is that when I have that inverse function inside its inverse, there are no restrictions on what x can be, on what I can plug in. You won't get anything that's undefined in that situation. So again, depending on your comfort level, if you want to try 1 through 6, hit pause and try 1 through 6, you can. If you want to walk through a few with me again, feel free to do so and then hit pause. Or if you want to just walk through all 6 with me, you can do that as well. All right, so tangent of inverse tangent of root 3 over 3. Root 3 over 3 is in the domain of inverse tangent, so my answer is just going to be root 3 over 3. Number 2, tangent of inverse tangent of 1,000. Again, the domain of inverse tangents, negative infinity to infinity, so 1,000 is okay. That's your answer, is 1,000. Inverse tangent of 3 pi over 4. Okay, I just want to walk through the logistics, or not the logistics, the mechanics of this, just so you can see how it works. Again, it's very similar to sine and cosine, but you may be saying, well, there's the domain for each of them is negative infinity to infinity, so my answer is just 3 pi over 4. It is not. You still have to think about the range of what inverse tangent will be. So let's just walk through and do the inside first. Tangent of 3 pi over 4 would be negative 1. So you can replace that tangent of 3 pi over 4 with negative 1. And then inverse tangent of negative 1, again, remember the range is negative pi over 2 to pi over 2. So where in that range will I have a tangent ratio of negative 1? That's going to be at negative pi over 4. Okay, so not 3 pi over 4, negative pi over 4, because my answer for an inverse tangent function needs to lie in between negative pi over 2 and pi over 2. On number 4, we have inverse tangent of 1. Okay, 1 would be in the domain of inverse tangent, but also in the range of, let me correct it. I want to make sure I said the right thing. 1 is in the domain of regular tangent. It is also in the range of inverse tangent, hence my answer is just 1. Okay, take a look at 5 compared to 3. They're identical except for that negative pi over 4. Okay, it would give you the same ratio as 3 pi over 4. However, that negative pi over 4 is within the range of inverse tangent. Hence, your answer would just be negative pi over 4. Okay, and then inverse tangent, or tangent of inverse tangent of pi. Pi is in the domain of inverse of tangent. Okay, in the range of regular tangent. Hence, your answer is just pi. Okay, tangent's a little bit trickier. You have to think about it a little bit, but otherwise not too different. Okay. All right. So your homework for tonight. Let me actually take a look at the sheet there. There are a lot of problems. Looks like we have 44 problems. A lot of them are pretty quick. They're all kind of like this. There's not really any thinking you need to do. So let's just say let's do every fourth problem. So starting at 4, 8, 12, 16, so on. And if you feel like you want to do extras, feel free to do extras. But just do every 4 starting at 4, and that way you'll have about 10 problems to do. That'll be a good mix for you. Okay, that's on worksheet 4. Starting at problem 4, do every 4. A lot of 4s there.